Yan. That is what is the general principle behind the use of modular ratio. So, let us have an example so that we can find out how to actually use this. So, problem 3. Find the stresses recall that the last two examples we are able to check that the stress and the moment are less than what is allowed by the cracking moment and the rupture, modulus of rupture. So, less than. So, therefore, first stage. So, now, we have an example for the next stage. This is what we call transformed area method, which is familiar to us in strength of material. Let us have some given values. We are familiar with this unit, PSI, modulus of modularity ratio do not have a unit because it is what? MPa divided by MPa. So, it will cancel out. So, 70 feet K, meaning feet kips. Wait. We have the given, so we can therefore analyze this into one single material, transforming one material into the scale equivalent on the other material. For example, we can do this in two ways. According to strength of material, we can select the base material. For example, using concrete. Therefore, transform the steel into an equivalent capacity concrete. Okay. So, since the steel is stronger than concrete, so the capacity level of the steel is greater, but with very small area here. So the area will become larger when we transform this steel material into concrete. Or the other way around, the second type is select steel as the base material, then the concrete material is transformed to the steel material. Since concrete is of lesser strength than steel, so the area of concrete will become smaller or it will shrink. Okay? So, we have a crack model now. For example, we have a crack model like this. This is the uncracked. So, from this point to this point, the concrete is already cracked. So, we have the following equivalent. So, concrete, equivalent, because we are using concrete as the base material. So, we have the same area, right? However, this area for steel will become larger because we will convert the steel into an equivalent, equally strong concrete. This is small steel convert to an equally stronger concrete. So, for example, this can be converted to how much? About times 10? More or less about times 10. So, this small times 10, that is the actual area. So that is times 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, about times 10. That is how we converted. So, in converting therefore, this whole material is concrete, but with the same strength as the steel. So now, concrete and concrete, we can now easily analyze this because they have of the same type of material now. And we can do this by the use of modular ratio. Without which, we cannot have this analysis. Okay? So that is the importance of modular ratio. That is, this is still in the strength of material subject. So for example, number 9 bars. So we are, take note, we are using English unit. So number 9 bars is how much? What is the diameter of number 9 bars? Number 8 bars is 1 inch. Number 9 is 1.128. Supposed to be 1.125, but that is not correct because those steel bars bigger than 1 inch is equivalent to what? To a square area, not the circular area. So the area is equal to 1 and 1. So that is the area for the number 9 bar. So what is that? 1 inch, 1 inch. Convert to circle. That's why the diameter is 1.128 inches. But the area is 1 is 1. So 3. So therefore, 3 square inches. What is 3? Therefore, 3 square inches as was indicated on here. So our area now, this area is 1 times 1. So 3. So 3 total area is 3 square inch area of steel. Okay? So there are 3. So 3 times about 10. So 30 square inches. About 10. About 10. But we can find out. So it's not 10, but 9. So 9 times 3. That is supposed to be the error because it is already given. Okay? Okay. So let us use the given values. If it is not given, you can compute for easy. How to compute for easy? E is omega 1.5 0.043 square root of C prime. Okay, take note. This is the first equation that we learned. So, normal. What is normal? About 2,400. Then this formula is for what? SI units. So you can solve this. Then we know what is this. So you can. So it is not given. It is not given, but it is given. So we can what? We can solve in reverse. We know this. We don't know this, but we know this. So we can solve for easy, and we can solve for omega. You can do this. Okay? Let us now transfer area here. This area is now supposed to be 9 times 3, which is 27. This area. Compared to 3. With the same one. The same dimension. This is one. This is on the same level. The centroid. The centroid of this. Take note, centroid of this. Centroid of this. Same. Okay? Take note. We can have different centroid if we have what? Depending upon the arrangement of the thing. Let this distance to be x. Therefore, this is 17 minus 10. Okay?